Scholars of the vertical world, I greet you well. Designers, innovators, dreamers, purveyors of squiggly line magic or statistics. Welcome to this brief contemplation, which is titled, When is a lift not a lift? Firstly, we need an introductory definition of a lift, so let's start by accepting that in history at least, a lift is a carrier that can move people and objects up and down. And if we accept this as a starting point, history will give us precedents which reach as far back as ancient Egypt and Greece. Indeed, there's a whole history of devices, from Henry VIII's stair lift to Louis XIV's secret lift to his mistress's apartment, and Catherine the Great's dumbwaiter that didn't tell what she was feeding or to whom. As the range of lifting devices has evolved, it's become necessary to tighten the definition. And by the 1970s, the definition of a lift had become permanent lifting equipment serving defined landing levels comprising a car whose dimensions and means of construction clearly permit the access of persons, running at least partially between rigid vertical guides or guides whose inclination to the vertical is less than 15 degrees. Well, I know that's a challenge to some erectors, but by and large we achieve it. When human creativity provides a new solution to a human need, we term this innovation. And innovation, by its definition, it must precede standardization. In an attempt to fill the gap between innovation and standardization, in 1992, as David has just explained, we received the Health and Safety Supply of Machinery regulations. Kicking and screaming, the vested interest groups rallied to slow the standardisation process and hang on to the machinery directive and keep control of the devices, which I believe fulfil a similar function but cannot fall under the definition of a lift. In the 2008 revision of the regulations, there was introduced this rather artificial speed differential of nothing less than 0.15. No matter what it does, what it looks like, it cannot be a lift because of this, which has now muddied the waters further. And almost 12 years on, the position isn't clear, even to us as experts in the field. So I ask you, when is a lift not a lift? A lift? Do we think that? Is that a lift? Looks like a lift, doesn't it? What about that one? Could be a lift. Looks like a goods passenger lift, perhaps. What about that? Well, no. That's a lifting bridge. But does it carry passengers between fixed levels? As it turns out, no. As it turns out, my father-in-law installed that in 1977. Now that looks like something from one of the Transformers movies. But is it a lift? It appears to have three car entrances, and it appears to be powered by a double-acting scissor. So is it a lift? Now that looks like a lift where the fitter's forgotten to fit the car roof. But is it a lift? Now that can't be a lift. For a start, it doesn't stop at any levels, and it doesn't have any doors. But it's called a paternoster lift. Well, that could be a lift, or it could be a lifting platform. That's simple. That's an inclined platform stair lift. Now that's not a lift, that's a building. But look at the size of the counterweights. That's the boat lift at Streppy Theroux in Belgium. Now, once again, surely, we've got automatic doors, we've got a complete car, that's got to be a conventional passenger lift. We would have thought so, wouldn't we? All right, that's a step lift. But to what standard? So, none of the previous photos showed us a lift that's designed to EN 8120 or even to EN 81.1 or EN 81.2. Most of the devices shown are in applications which are within the scope of the standard to which they were designed. This, however, is not always the case. Lifting platforms are not designed to transport goods, but you can often find these in retail mezzanine applications and used regularly and sometimes solely for that purpose. Using a device outside the scope of its design is potentially dangerous. For example, a designer of a stair lift may reasonably not identify risks associated with it being used to carry a dangerous substance such as liquid nitrogen. This type of event would be considered very unlikely. Well, that is, were it not for the fact that the British Compressed Gas Association Code of Practice CP30 recommends the installation of a stair lift for that very purpose. Where goods are to be regularly carried, a disabled lifting platform shouldn't be used. The maximum travel for lifting platforms and slow-speed lifts should be limited by the maximum time to destination analysed by simulation. The maximum time to destination should be less than 180 seconds in residential applications, in my opinion, and in commercial applications 120 seconds. This would probably reduce the maximum travel for slow-speed lifts to 9 metres in residential and 6 metres in commercial applications. And if it's not, then it may be that a person with disability could argue that they were being discriminated against due to the poor service provided by the access arrangements. All vertical transportation systems should be designed with an arrival rate for persons with a disability of at least 8% of the building population per 5 minutes. And this applies to both residential and commercial applications. But for places like residential nursing homes, where the arrival rate may need to be higher, conventional passenger goods lifts should always be considered. In many public access applications, one lifting platform will not provide adequate handling capacity. Lifts installed under the Lifts Directive are subject to a design and installation procedure which is approved and monitored by a notified body, and in the UK are subject to a comprehensive final inspection based on the BS 8486 series of standards. Devices supplied and certified under the supply of machinery regulations may not be as carefully selected, risk assessed, designed, installed or tested. Now there is a body of opinion which holds that there may not be equivalent safety in machinery directed devices when compared to lifts installed under the Lift Directive. It may not be equivalent safety, but the argument runs that there is sufficient safety. I don't hold with that body of opinion. There can't be enough safety if there are accidents and incidents occurring. So I had a look back through the LEA safety notices, and I looked back 20 years. And what I found was that over 30% of the safety notices issued by LEA in the last 20 years have related to lifting appliances other than lifts themselves. This year, the HSE have reported that there have been a series of incidents involving lifting platforms with landing doors that have opened when the carrier isn't even at that floor. There have also been instances of premature driving up failures on lifting platforms, including those designed to transport goods. These types of events, sadly, have occurred before with tragic consequences. The Highclere Rochdale incident in 1985 is the case study I have in mind. BS 5900 1980 was a specification for powered home lifts, and it was intended to be a domestic home lift standard. It assumed that there would be very low usage on a device that was installed in a private residence, perhaps 10 trips a day, something like that. So partly to save space and also to save cost, small worm wheel gearboxes with 75mm centres were utilised. Several manufacturers supplied very similar products during the early 1980s. Sadly, this type of lift started to be sold into local authority and private residential care homes, where usage was far more extensive than the design had assumed. On the 2nd of September 1985, the gearbox of the lift at Highclere Nursing Home Rochdale, which was designed to be S5900, failed whilst carrying passengers. 2 of the elderly passengers died from their injuries. This, much to the concern of the Health and Safety Executive, was not an isolated incident. On the 11th of September 1985, the Manchester director wrote to all the HSE area directors advising of the issue, and it was discovered there had been several fatalities in other areas as well. Over the next 6 years, various modifications to the home lifts designed to be S5900 were attempted, aiming to prevent further accidents. None of these preventative measures applied or alternative machines supplied were able to limit the accelerated wear in the worm wheel gearboxes. Safety standards are only one element of a lift design. Lifts need to be able to move people and goods, and in doing this they will need to perform correctly with acceptable ride quality for a suitable number of starts per hour and operations per annum. And they need to be reliable and have a life expectancy worthy of the significant investment they represent. Our brief review of the history of lifts has revealed that necessity is the mother of invention, and the meaning of this anonymous proverb is that innovations are chiefly driven by human need. Sadly, in the construction industry, cost reduction can sometimes be the strongest necessity. In conclusion, I believe that equipment supplied to internationally recognised standards that are based on risk assessments carried out by teams of experts in their respective fields, guiding experienced designers, consistent manufacturers, and competent installers and testers. That equipment will be safer, more reliable, and fit for purpose. They may be more expensive than devices that have not gone through such a rigorous process. Other devices supplied by a different route may be sufficiently safe, but they may well fail to perform or last as the end user expects. Just because an alternative to a conventional passenger goods lift can be installed doesn't mean that it should be installed, as it may not be suitable to handle the traffic flow of the building. Buy cheap and you buy twice is another proverb, and it's based on common sense. Thank you.